Okay, so my name is Arkadiusz Kondas. I came to you from Poland. I work every day as software architect, and when I find some time, I run ultramarathons and blog. But it's the least important slide here. So let's see what I have planned for you today. And we'll start with a little theory. And then will be a lot of meat and code. I think this topic will be interesting for you. It's prepared especially for this conference. And in the end, we have some kind of summary. So let's get started. And probably every one of you hears a lot of good things about machine learning and artificial intelligence, but most probably feel the same as this tweet. I would like you to be able to understand well what machine learning really is after this presentation. So let's quickly see why machine learning can be interesting. So I have little problems with this thing. Okay. First, machine learning can personalize content for recipients. And here we have example from Spotify. I hope it's popular in Russia. In my country it is. So when you rate your music in Spotify, they can suggest you something called like Discover Weekly playlist, and it's worked very well, at least for me. And Spotify is very willing to share knowledge about machine learning. I have two other examples for content personalization from my country. This is book portal and film portal, when you can rank books or films, and they give you back recommendation, and they also works pretty well. You can find really interesting books if you rate them. Okay, so next, second branch that enables machine learning is data mining. With a huge amount of data at your disposal, we can discover interesting patterns here. And the network was loud about certain story related to it. The marketing system sent an email to a client, an offer to buy article for a pregnant person. So what's happened? It turned out that the purchase of his card was done regularly by his daughter, and the system detected a suitable pattern for pregnant woman and suggested a solution. So this is very interesting. And of course, that guy didn't know that his daughter is using his card. Okay. Another option here is the ability to mimic human and replace certain monotonous tasks which requires some intelligence. Here we have example of extracting information from image. We can send image to the trained model, and he answers us what is in it with text labels or something like that. You can find really good trained neural networks in the network. And here is example with chart from the competition for the recognition of human faces, and the red dotted line is the human possibilities. So as you can see, machine learning is really far better than human in certain tasks, of course. And now last but not least, with machine learning we can develop systems specialized in a specific task. And here we have example of competition that is organized by Amazon every year. The task is to pack items from the bookcase into the box as soon as possible. And the robot must be well trained because the layout of these shelves and boxes is not known before the competition. In particular, it may threaten people performing. So, when I was flying to Russia, I reading article in the brochure on the Gazette in the plane, and it was talking about the fourth industrial revolution, because in particular, it may threaten people performing repetitive work, and it can replace middle-level workers and officials or assistants. So this is really interesting times. And you can ask a question, why now? Because the machine learning was the name, and the main algorithm was coined in 1959, but two things were missing: the dataset. Now on the internet we can find a lot of very interesting collections suitable for machine learning, and is, as you can see later, it's very interesting. And the second issue is the computation power, but now this should be clear to everyone that at the moment even our laptop are fast enough to be able to train a really good model in a reasonable time. All right, so what are the ways of learning? We have three main branches. We can split machine learning in different divisions, but we don't have much time, so we can stick with these three main branches. We will start with supervised learning, which is the most intuitive one. As you can see, we have some inputs data. The data, okay, I can show you. For example, it can be images of fruits, and we have labels. And we put both of them to the model and train the model. After some training, we want to put only the data to the model and expect its label. So for example, I can put the apple image and the model tell me this is apple. And this is supervised learning. Note here that label can be either categorical or numerical. So we will talk about this a little later. And we can split supervised learning in two more categories, which is classification for categorical data and regression for numerical values. These values that are continuous. For example, price of the house, as you can see later. All right, next we have unsupervised learning. Here the task is more complicated. In this case, the algorithm doesn't get the expected output, labels or numbers. He must find the right rule to characterize the entrance and, if possible, generalize it. So, for example, one can say that he must find the pattern, or mine the pattern. And in supervised learning, we can split it in another two divisions here. As we can see, we have dimensional reduction. We will have no time for it today, and clustering, with maybe I find time to show you. And in the end, we have reinforcement learning. This is the last category of these three branches, and is often very popular in social media, which is not surprising at all, because it's very interesting with games. So this method assumes that the system operates in unknown environment. The model doesn't know anything about the environment, but there are no specific input and output, but the only information that student on system receive is reinforcement signal that can be positive, which means the regard, you did something correct, or negative, when the model makes a negative decision. So we can say this is a punishment, you did something wrong. And as you can see, there's a whole bunch of categories that refers to reinforcement learning, but I can say that this mainly refers to the acquisition of skills. So we can we can throw model in some unknown environment, and he will be learning some skills of it. So it's also very, very useful. Okay, and with this theory, we will jump straight to the real life problem. And now we want to solve a problem how to predict reality price in Russia. And this is the problem of house evaluating price is the problem of supervised learning. So we will be having some data entrance with labels. We train the model and we will want to predict the price of the apartment or house or something like that. We will see. And the price in the dataset will be in rubles, I think so. but I'm not sure. And the dataset we will be using is the, I don't know how to say this correctly, Sberbank, yeah? Okay, Sberbank Russian housing market. And this is a dataset from Kaggle competition. This is a website which I can call some kind of mecca of data scientists, or maybe GitHub for machine learning scientists. I will show you later this. Okay, exciting? So let's look like dataset looks. So it is a CSV file with 292 columns and something about 30K rows, 30,000 of rows. Here's example is very messy. We can see the whole things. It even don't fit on the one slide, but you can imagine more columns there. And let's take a look at one sample. So one row in this file is, for in our case, is one sample equals 292 columns equals 291 features. The last column from this data set is our price, so the price of the apartment. This is the attribute we want to predict. But in training data, we want to make it so our model can learn it. And here is example structure of it. As you can see, there is, for example, Foursquare total area in square meters, and floor, max floor. So this is features that describes every apartment. And I already analyzed it, and there are 276 numeric values and 16 non-numeric values. And if we have time, I will show you how to deal with non-numeric values, because this is also very interesting. Okay, now we have time for very cheeky product placement, because in the next slide I will use code from this library, and I think you can guess who is the author. So let us start from loading the dataset from this file. You can download it from the website with link that I show you, and this is one file with train.cs file. I changed name here, but you can use a special class, CSV dataset, which loads all the samples in one simple array. And you can use other class later. For example, native array or files or images. This is more class like this when you can load the sample. And this CS file dataset can get your column names, so this is also interesting and can be useful. And let's analyze how one sample looks. So it's pretty easy. It's associative array with all the data loaded, 292 columns. No, 291 columns, because it's one sample, not the target, not the price value. So what we can do next with this? We want to first select some kind of feature, because sometimes we would like to focus not on all features at once, and the collection can be quickly filtered with column filter class. This is separate class, and I will show you later why it's separate, because you can use this in more complicated structure. So as you can see, I have samples and filtered only columns. This is example from with other things, but that we have start with 4 columns and filtered only these 2 interesting columns for us in this case. Okay, let's see what is later. Not this, okay. And as some of you already pointed out, input data is loaded as a native array, so everything is string in it, every number is string. So we must parse it some kind of way, and the solution for this is number converter. It can convert all numeric values to numeric values. And it has nice and interesting feature because it can convert non-numeric data with some kind of placeholder. This can be useful if you can deal with data that, for example, we have sample or column with all values are numeric, but there are few values with some kind of string or maybe other things that can't be parsed. So you can replace it with null. And in the next slide, I will show you why it is nice to do it. And another feature, it can also convert targets. So this second array with our prices, it can also be converted with this. Okay, and what's about missing values? So we can analyze this data set, and this graph is showing you the number of missing data and the data without the price column. So as you can see, some features missing 40% and more values. So this can be very problematic in model training because we have do something like with these missing values. And the solution to this problem often depends of the type of the data and the problem itself. So it can be complicated, but here is one of the possible example is the inputter class, and it can replace missing values with chosen strategy. So as you can see, we have some kind of samples. Each sample is in one row, so we have 4 samples here, and we construct new inputter class, which with null as first argument. So we will tell the inputter replace null, and we will construct with mean strategy. It means for inputter that will be replacing all nulls with calculated means. And in default configuration, it's calculate mean for column, but you can switch it to calculate mean for the row, for example. It also can be handy. So we can fit this inputter. This is some kind of training for it. We will take the sample and replace all the sample with means calculated from the fit sample. In this slide, is fit and transform are the same samples. So as you can see here in comment, all new values are replaced and can be used next. Okay, so next is the model selection, and this can be very surprise for you because model selection or algorithm selection is very most simple task. Here we're gonna use some kind of regression. This will be decision tree regressor, and we'll try to construct it with some parameters. We can talk about this later. And later at the end, I show you small cheat sheet that you can use to select the correct algorithm. So you can don't even remember all these names of algorithms. And here we construct the model, and we will train it. So we give the model samples and the targets. And this is the task that can consume most time. It can train from seconds to hours to even days for complicated models. And trained model can use predict method to predict samples. So here we can predict some samples. We can get him a sample without price, and he will try to guess the price. So let's go next and see what we can do. The next step usually is validation of trained model, and this is always worth to check how good is it trained. So on the left side we have examples that are real values. This is real values from the dataset. So I think it's 5 million, so it is rubles for sure, maybe. And on the right side are the value provided by our model. So this is the value that he predict without knowing the price. So as you can see, there are some good prediction. For example, the first one is pretty good, but as you can see, the for example 5.1, it's pretty not good. It's different 2 times. Yes, it's 16 millions and this 8 million. Okay, typically such tests are carried on separate set. We can call this set test dataset or test set. And it is important, I can show you later why, how to construct it, that train and test dataset must be different. It can, our model can see test dataset during the training, so you must prepare it. In this Sberbank competition, the test and train dataset was already given by him because it was a competition. So you train the model and test the dataset and send them results, and they validate it with some metrics. And for validation, we can use metric, and usually there are bigger problem here because each metric is suitable for different type of data, but we will not go into details because every metric is very complicated. And in our case, the problem should be assessed with the help of mean squared logarithmic error. Sounds very scary, but it's only one class to use it. And you can read it on the competition website or maybe on documentation that this is metric that is best to use when targets having explanation grow. So in our examples, the price of house can be from lower to very high value, and this is problematic. So mean squared is pretty good with this scale. Okay, so let's look like our model is trained. And best result from Kaggle that use best model that is trained with gradient boosting. It's more complicated example that our decision tree regressor. But for the test dataset, the result is 0.3. This is the winner. Yeah, this is the winner. And in our model, very simple model where I only choose 4 values for it. As you can see, test dataset have 0.3, so test was really good, but the train dataset, which was sent to the Kaggle, was 0.4, which was pretty worse because this is logarithmic scale, so the difference is more bigger than you think. But I think it's for the start, it's pretty good. Okay, and when we have our model, we should take next step to persistence. And it is always worth to save it because the training can took some time. And thanks to the model manager class, you can save trained model, as you can see is model, to some kind of file. This is now the implementation is very simple. It's just serialized object, but we can add here some kind of compression to reduce its size because this model can be sometimes huge, from couple of megabytes to even gigabytes. And later you can use model manager to restore the model and predict samples. So when you do the training, it's very simple to predict next sample because you have to restore the model from file and predict next sample. And it's pretty handy and simple. And of course, each operation that I showed you in previous slides can be done separately. The extraction, transformation, and normalization. But why? We can use the workflow model, the workflow line. And in the workflow, we have special class called pipeline, which in itself is also a model and also can be used to written to disk. So here we have pipeline with our dataset, with our model, and we start to construct it with filter. As you can see, I only filter 4 columns. Next, I will convert them with targets. Next, I will replace missing value, and finally, I will use the decision tree regressor to train the model. And whole pipeline is also a model, so you can also save it to the disk and restore it later. It's very handy because in the previous, when you predict sample, you must also remember to transform the sample. Yeah, you must also replace missing values and so on. So it's not only that you load model and predict, but you must transform all these things you have done for train dataset. So pipeline can be really handy for this. And we have here feature union. This is the newest toy from PHP library. It's not released yet, but you can check it in dev master branch. And feature union is also very handy because you can join pipelines and extract models and extract features from two kinds of types. For example, here we have first extract the sex of the people and transform the text value to the numeric value. This is one hot numeric encoder. We're not going to the details, but it can replace categoric values with numbers, and you can use it later to train the model. And next we extract age and income and replace missing values. And whole union can transform our samples, so we finally get all the features in one array that you can pass to the train and predict method. Okay. So let's not forget that a trained model is worth sharing somewhere, I think, if it's trained good. And here I prepared a nice example with HWS Lambda. In my opinion, it fits pretty well on this. So we can throw trained model to the Lambda and get the endpoint. There's this working endpoint. If we have time, I can show you that it can work. You can try it later. So we, as you can see, it's very simple endpoint that can, you must provide him 4 values and the endpoint responds you with the price. So you can check it later. And here is the Lambda code, at least it's slice. So as you can see, it's only load the model and return some kind of JSON response. Very simple, very naive. But this JSON can be later consumed by some kind of other API or I don't know. So as you can see, new model, restore from file and predict with some kind of round and just post value. And never do this on production, it's only demo, remember. And this is now the whole code from which dataset I show us. I even don't know if it fits. It didn't. So this is we starts with pipeline. Then we train our model. We see our metrics, and we load our test dataset and save test dataset to CSV file. This is file that I will be loaded to the Kaggle so they can evaluate my score, and I save my model. So this code was used to this Kaggle competition. So if we will remove this saving file and so on, as you can see, there's a couple of lines, and you have trained nice model for predicting house, only based only on 4 columns. And remember, it's very naive. It's a simple example just for this presentation. In real world life, you want to use all the samples and features that you have and can collect. Okay, so if we have some time, yes, I think we have. We can take a look at another examples. So here we have classification, and this is the iris flowers that we can split in 3 different species on categories. I don't know what is this. I am not flowerist, but we can split it, and this split is done by measuring these 2 petals. we can measure the height and width. So as you can see here, we have data sets. It is a canonical data sets for machine learners because it's very simple. 4 features, 1 category, and we can predict the iris species from this data set. And we can choose the algorithm to train our model. In this case, as you can see, the iris dataset is already in PHP-ML library. We can load it and without copying from the network because it's a very small dataset with 115 samples, something like that. And here, as you can see, we are doing this split for test dataset and train dataset. So in split, we get train samples. And in this case, the model is K nearest neighbors. So this is simple model for classification, also very naive. It works on computation of K nearest neighbors of each sample. And as you can see, I can predict sample. So I predict all test samples. This is only samples without targets. And in this case, I will be using precision metric, which precision is percentage of correct prediction. So correctly prediction species of iris in our example. And I can visualize accuracy. In this case, with K nearest neighbor, it can reach 99% or something like that. So it's pretty good for this dataset. And one more example, it's very nice with visualization. We have data sets from air pollution's website. I don't remember name, but here we have 2 features. It's GPS data, latitude and longitude, and our target or label is the air state pollution, is the state of air pollution in that place. So first, we want to visualize it. It's also very good and common practice to visualize your model. So we want to see what looks the data. In this example, I convert the air condition level to the color and draw it to the map. So as you can see, that's all the GPS values and air condition state. And this is very interesting because, as you can see, we don't have data for all the places. So let's try to predict it. And here is the code that makes the prediction. And as you can see, we load dataset from CSV file. We use K nearest neighbor, so it's very naive algorithm. But let's see how he can check with this. And we do this only for small amount of points. As you can see, I predict value in small area. And save this data to CS file and try to visualize it again. And in this example, we'll see the effect of visualization for different key parameters. So this is, for example, 3 neighbors. Here we have 4, 5. So as you can see, it can predict different values for different parameters. It depends on the problem you are solving, so it's not so obvious which parameters to use. Okay, next we have regression, but I think I can skip regression because the regression, that was the task we are dealing with Russian houses. But here's very simple example with price of the car. So here we have state of the meter status, distance of the car, and the price. So we can really simple drive it to the some spreadsheet. In spreadsheet, you if somebody use spreadsheet in more advanced ways, I know that people that use, you can even do machine learning in spreadsheet because the regression line is it. Machine learning things. So, or maybe the regression was first before the machine learning. And yeah, let's look like the code looks for this data set. So here we have distance of each car and the target in this case is price of the car. So as you can see, I can expect that the longer distance, the lower price. It's very simple model, very naive, but you can use it and predict it. And here are two more ways we can. Oh, it's a regression thing, so let's skip it. And next case that you can do, this is now unsupervising learning, is clustering. So this is very simple example because we have here data sets from Chicago fire department. This is the places when the fire occur in Chicago. So in each place there was one fire. We can try to visualize it, and as you can see, the fire was everywhere. This is the data set from couple of years, maybe longer. So for example, we can try to cluster this data set, and as the result, the model so we can run this model on the collected data, and we see that he managed to determine few clusters. And for example, in these places, we can build some kind of fire station or something like that. And this is a pretty simple model, so only for show. But you can imagine that the problem, this fire problem, was only have two features, two dimension. But you can simply imagine that what would happen if the problem have more features. So we will have more dimension. Here we have an example with 3 dimension, and good luck for someone that will try visualize it 4 dimension and more. But you can still cluster this data with machine learning. And here is a simple example of that. We have samples here, and it's all one array of samples. We run classify with k-means. It's also some kind of algorithm for that, and he split the sample into algorithms, into cluster. As you can see, first cluster is near, and second is also near. I make special data for this. Okay. Next, we have feature extraction, but I think we don't have much time to talk about this more. But here we have a class that can transform text data into array. It's simple technique that can, in simple words, calculates the count of each word in each sentence. But the topic is more complicated. We don't have time to speak about this. And more, we have model selection. So in error example, you see the split, the random split, and the second parameters is to determine the size of the set. So you can make a split for test and train data set as much as high as you want. And next we have also stratified random split, which split data in more fair solution because it's not completely random. For example, we have here data set with 4 A labels and 4 B labels, and imagine what happened if we randomly split this data in half. All train samples will have A labels, and all test will have B labels, so our model will completely fail with this. So stratified random split can choose random samples, but taking in advance these labels and split it randomly and separately. Okay, there is more features. As you can see, you can read more on GitHub, and I think it's time for summary. And I hope that now everybody was asleep or gone to dinner. But all I want to show you is machine learning is all about the process, not about the algorithms. So first and most important, you must define the problem, and it's really hard to define a good problem. Next, you must gather your data, collect it. This is also very complicated because not always every data is available for everyone. And next, you must, as you can see, you must prepare this data for machine learning. It's also time consuming. This data set with Gaussian pricing was already prepared. It is also missing value, but it's prepared by this bank. Next, you select the algorithm. There will be cheat sheet for that. It's very simple, usually. Then you must train a model. That's all simple, and then you must tune the parameters. This is we not managed to address this issue, but as the rule, all algorithms have different parameters, and it's also big and interesting topic. But we can do separate presentation about parameters of these algorithms. Next, you must select final model with the validation and metrics. And then you must deploy it and maintain. So after time, I think, for example, in our housing problem, you must retrain the model. For example, you have data from houses from the next year. So you want to make your model better later. And you must also, don't forget to retrain it. And it is also hard task. And okay, so here is a cheat sheet to choose the right algorithm. As you can see, it's from this Python library, scikit-learn. It's also very popular in machine learning engineers. So this is, you can start here, and its first question: do you have more than 50 samples? No. Get more data. Yes, I have more. And next, these data are categorical or numerical. So as you can see, it's split between classification, regression, and so on. And you can easily find in the end the right algorithm for that. And yeah, that's pretty good for the begin. If you want more advanced things, that you must read some more complicated papers and studies. Okay, so the most important thing is the question. Data is secondary, but you must remember that data is also important. And many algorithms and techniques you can use. Really, there are many, hundreds of algorithms different. Every algorithms have a paper that some kind of scientist study and deploy this model and train it. So it's also a very interesting topic. And as you can see, application can be very simple from couple of lines when you prepare your data training model, but also can be extremely sophisticated when you must collect data from 15 sources, join them into one array. The array is too big to load in the memory and so on. So this problem is really, really complicated. But some algorithms can be trained in batch. You can train algorithm in steps and load, for example, 100,000 of sample, train it, remove it from memory, and load next 100,000 of sample, retrain the model, and so on, so on. So it's it is possible, but it's also very complicated. And you must remember that sometimes the model fail, and it's not so worry, because it's difficult to find correct answer. It's you can find really nice data sets in the in the internet. So this point is maybe not, you will not face this problem on the beginning, but when you start working with production data, you can assume that some kind of data can be predicted. You gather all this data, train the model, but in the end, the model is so bad that you can flip the coin and it will be better. So it happens. And unfortunately, base math skills are important. You must at least know these metrics that I show you. This is basic statistic and linear algebra. So you can learn it in approximately 2 months, maybe, maybe fast. And one more thing, it's very important. I show you this on previous slide that you must visualize your data. Don't trust the numbers and metrics. It can fool you. Here we have interesting example. As you can see, is all these graphs, all this visualization have the same metrics, the same x mean, the same y mean, the same standard deviation, and the same correlation. So as you can see, it can be simple lines, a star, maybe some ring, but also a dinosaur, which is completely crazy. But all the metrics are the same for this data. So I suggest you better visualize that you don't have a dinosaur in your datasets. And there's this very interesting, here was the GIF, but it not loaded. And you can find it later. So this transformation of that dinosaur to other GIFs, because this guy, I don't know, is the author, but he invent the method that can transform one dataset to another, and the parameters can stay same. So it's pretty crazy. And yeah, there's also a very interesting example with the first slides when we have images that model can predict. For example, we have image of mountain, and the model can say this is the mountain. You can see, you can think that this trained deep network model is very intelligent, but I think, in my opinion, it's very stupid, because you can find, I can show you later after the presentation, that there is interesting study called one pixel attack. There is another guys who train the model in that way, then can change only one pixel in the image, and the model has wrong. For example, you have image of the mountains, they change only one pixel, and the model said, oh, this is the square, or this is the place. So this is very crazy. And it's also very interesting slide, especially for PHP community. It's very simple performance test. So in this metric, I will write simple, that's even not I, right? This I find something. And this is a simple script that calculates and classifies the iris datasets and do it in the loop. So in PHP 7.0, we have 200,000 instances in 30 seconds. Here is, for example, Python 2.7. 3.6 is, I don't know, even lower. Here's, for example, Node. And the last one is Java. I don't know if you want to see it. But remember, it's very simple, and it's only curiosity. Remember, it's a compiled language. Yeah? So, but as you can see, most of the data scientists make their calculation in Python. Not only because of that, but remember that Python have a library optimized for GPU, so they can use other processes to calculate the model. But remember that simple model can be calculated very simple with PHP. And this is also a repository of the code. You can run it yourself, and as you can see, it's PHP 7.1, which is quite faster, 7.2, and 7.3. And what's double speed? Yeah, double. Okay. And one more thing in the end, it's my hobby, I would say. And sometimes it's difficult to capture the moment in which we can collect these metrics from your domain problems. And event storming is a great tool that you can carry out the domain modeling process and captures the metrics. Here you have an example from a final session from one of the team. And these little blue cards are the metrics cards. So after a modeling session, we have complete metrics for our model. So this team is now in the phase of collecting all these metrics and can try to predict something in the end. All right. So where to begin if you want to learn something new? Kaggle is very good website. As I can say, it's Mecca for data scientists. And when you create account on Kaggle, you will retrieve emails with tasks and courses that you can do every day. It's very simple task. It starts with Python. You can learn Python, then you can train simple model, and so on, so on, so on. And you can share your model in Kaggle. It's called kernels, so we can share it with other. You can discuss it, comment it, and you can find a model for this Sberbank housing problem that are trained for and win this competition. So it's very interesting. And I can suggest you 2 more books. It's also very interesting books. First is The Data Scientist from Scratch. This is the book where you will be implementing all the algorithms from scratch. No framework, no library, everything from scratch. For me, it was a very interesting book. And the second is very popular in data scientists and machine learning engineers is Hands-on Machine Learning. I don't know how to pronounce it, Giron. And now you can grab second edition of this book. It's printed in color, so it's very nice to read it, and you can learn everything from machine learning with this, even deep learning with neural networks. So I can definitely recommend this one. It's one of the best books I read about machine learning. Okay, so this is the moment when I can see if you understand something.
Well, let's first of all thanks Arkadiusz for his talk.
Thank you very much for the talk. I've got 2 questions. The first, how do you think, what are the main restrictions of PHP or maybe the ecosystem around it that make PHP currently a worse choice over Python for machine learning? And the second question, what needs to change in PHP or the ecosystem, especially in light of the upcoming changes like FFI and JIT, that could make PHP a viable choice over Python for machine learning?
Okay, so I will try to answer both questions in the same time. The main missing features are libraries and tools, because PHP-ML is a very simple project. I do it only in my spare time, free time, and I don't have time to implement all the algorithms, but this is one missing thing. Second thing is the tools for visualization. In PHP, you don't find anything for visualize. For example, this example with map, when I draw the color points, it was made with Python, because there is one lib. You can do this visualization with 2 lines. It's very, very handy and easy. So this is things that are missing, because the performance is not the most important things. And third things is the lack of support for GPUs, but with PHP 8 foraging function interface, yeah. FFI, it can change, but I don't know if anybody finds some time to write this, because everybody works for Python, for example. Yeah? You have Google team that work of the Python that you can load GPU, and even GPU is not the best tool. And Google Cloud, you can find TPU, Tensor Computation Unit, which is optimized for machine learning task. For example, if you have neural network to train, with CPU it took, for example, 10 hours. With GPU, for example, it will be 1 hour. With TPU, will be 1 minute, because it's optimized only for machine learning. And there are Google Cloud is the only one place when you find this GPU units. So that's it.
Sure.
Hello. I have 2 questions. First is which algorithm did you use except array? Maybe SPL fixed array or SPL structures. And second is how much algorithm did you realize in that library?
how much there are 20, something about 20 algorithms. And with SPL array, I didn't use it in, or maybe, I don't remember even. You can check it on GitHub.
Okay, we are lack of time. If you have any questions, Arkadiusz is here, so you can find him and talk with.
And don't forget to leave me some feedback and ask me.
Yeah,
anything.
of course, provide feedback for. Thank you very much.